This page is the reference sheet that we're going to use to actually conduct our first hypothesis test. It'll be very exciting. We're going to conduct a hypothesis test for a single proportion. Now just look at this page and understand what's happening. Up at the top we have the StatCrunch instructions. StatCrunch doesn't do the test for us, but it'll help us along the way with some of the calculations. These are the requirements that are needed that we learned about in Chapter 8 for the central limit theorem. We only complete them if they're requested. They're not an every time thing. So only do them if they are asked for in the problem. It's the random independent normal piece. Notice, by the way, that for normal you need P0 and Q0. Those are from the zero hypothesis, from your null hypothesis, H0. So whatever value you assume to be true, that will be your P0. And then you'll run your 6 steps. And of course, it's all well and good to look at these, but let's actually do one. Okay, so in 1947, 24% of adult Americans believed raising a girl was easier than raising a boy. In June 2018, the Gallup organization polled 1,500 adult Americans, of whom 408 felt it was easier to raise a girl. Does this result suggest that the proportion of adult Americans who believe it is easier to raise a girl has changed? All right, so we're going to begin with the hypotheses. Now, the hypotheses are always the null hypothesis, which is H sub 0, right? Subscript is 0. So H0 and H1. Now, because this is proportion, and it says the word right there, which is kind of a giant red flag, we know that our parameter is P. P for proportion. So now it's a question of what proportion do we assume to be true unless we can prove it otherwise? Well, we assume the past holds. We assume that whatever it was back in olden times is what it still is. So when we see this in 1947, 24%, that right there, that's our P0. That's 0.24. Oh, I have to change to a different marker. So I was writing with a highlighter and that is not coming through clearly enough. There we go. So this is your P0 right there. That's the value you assume to be true unless we can prove it otherwise. It's the proportion for our zero hypothesis, for our null hypothesis. All right, now we just have to figure out what direction we think we're going, because once you know that one's 0.24, then this one's 0.24. It's always the same number for both. It's just a question of what symbol will we use. Is it left-tailed? Is it two-tailed? Or is it right-tailed? All right, so you want to look for a key word in here. And the key word is changed. Right here. If we look back at our list in section 2.1, changed is a not equal. Right? It's not giving you a particular direction. It's not telling you less than or greater than. It just is what it is. Well, there we go. We have our hypotheses. So technically, this is step 1 for our hypothesis test. But we're doing that ahead of time because we want to verify the requirements. And the requirements, if you remember for the normal piece, need P0. So you can't really check the requirements unless you know what the null hypothesis is. In this case, it's that P is equal to 0.24. All right, so we're going to verify our requirements. So that would be random, independent, and normal. Same things we saw in Chapter 8 and Chapter 9. Now, random is really easy because it said somewhere. Oh, it didn't say it. Oh, I'll have to fix that. Well, the way Gallup runs its polls is this would be 1,500 random adult Americans, or I'll put that in. So I'll add that word for next time. So, but for the meantime, so it will be yes, given. Technically, it's just safe to assume, right? But I'll add that in there. That's a typo. All right, independent would be yes because, and let's prove it. To prove independence, we need that little n is less than or equal to 0.05 capital N. Little n is our sample size, and our sample size was 1,500, right here, the 1,500 random Americans. So 1,500 is less than or equal to 0.05 of, and then capital N is 250 million. Or you could write the words all adult Americans. That would also work. Right? So this is a huge number. So this is all U.S. adults. Right? That's what that is. Well, obviously, that's really, really, really big number. So this is, of course, right? We don't have to bother finding the number. It's huge. So we know that 0.05 of 250 million is ginormous. So we're good. And ginormous is not really a number, but we all know what it means. All right, so now let's prove normal. I'm betting it's going to be yes. It usually is, but let's prove it. So it's n times p0 times q0. All right, n was 1,500. P0 is 0.24. Right, it's the value from our zero hypothesis. So this is P0 right here. Now Q0 we have to go find. Q0 is the complement of P0. So I'm just going to make a little note up here. Put it right here. Q0 is 1 minus P0. Right? We learned that technically back in chapter 8. Right, P and Q, actually chapter 6. P and Q are complements of each other. Right, P is the probability of success, Q is the probability of failure. So we know that's the case. So Q0 would be 1 minus 0.24, which is 0.76. So this is 0.76 right here. All right, so we just need to find those values. I will grab Desmos. Let me pull away from my StatCrunch here, so just so you can see it. There, it is 0.76. I didn't lie to you. All right, so 1,500 times 0.24 times 0.76 makes 273.6, which is bigger than 10. So this is a yes. So we have 3 yeses. We are good to go. We've verified our requirements. All right, now we're going to actually test the researcher's claim. So I don't know. For me, I always like to do all the steps. So even if I've done one step earlier, I'm going to say it again. So P is 0.24. P is not 0.24. There's step 1. Step 2 would be alpha. Alpha is our level of significance. So this is 0.01. Everybody loves alpha because alpha is so easy. Okay, step 3 is the hardest part because step 3 has this big formula. Now you could technically write either side of it. They both work, but generally we stick with the one on the right because we know those values. So Z0 is P hat minus P0 over the square root of P0 times Q0 over N. Right, that's the formula right from the page. Okay, so, well, I already know what P0 is, right? So if I write this, and I already know what Q0 is. So P0 is 0.24. So wherever there's a P0 in there, I can put 0.24. Q0 I also know is 0.76, right? And we're multiplying those two. That's a times dot. We know N is 1,500. So the only thing we don't know is P hat. P hat is X over N. So if I go back up to the top and I look, here's X. Here's the number that said they felt it was easier to raise a girl, and here's N, right? N is always smaller, or excuse me, N is always bigger than X. X is always smaller, right? Because you have to make a proportion out of it, and it has to be between 0 and 1. We learned that, well, back in chapter 5, right? Percentages, proportions have to be, right? So it's 408 over 1,500. So I can just write that, 408 over 1,500. I don't need the particular decimal. I mean, you can write the decimal if you so desire, but it's not required. All right, so we want to find this value. And this is a pretty ugly formula to type into Desmos. You could do it, but it's pretty ugly. So what we do is we make StatCrunch find this answer. And StatCrunch will also find step 4 for us. So we're going to do all of this at once. All right, now how do I do this in StatCrunch? Well, the instructions are right here. Stat, proportion stat, one sample with summary. So let me go to StatCrunch. Let me open a StatCrunch table or spreadsheet thing. It's not really a spreadsheet, but it looks like it. So stat, proportion stat, one sample with summary, right? Data would mean I have data sitting in the sheet behind, and I don't. All right, so my number of successes was 408. That's X, right? And N is my number of observations, which was 1,500. And I want to conduct a hypothesis test, but it's not of 0.5, it's of 0.24. And then I do indeed want this to be a not equal to, so I'm going to leave that. And then I want to make sure I turn this little box on down here where it says we're going to have the p-value plot, because that will make it so that we have step 4 done. And then we say compute. And there it is. So I can see my ZStat right there. That's the answer for step 3. There's my p-value for step 4. And actually, if you hit the little arrow and go see the second page, you can actually see everything you need on the second page. You don't really need the first page much, right? The first page just verifies it is, in fact, the HO, and they call it HA, right? Because A is alternative. So different computer programs do it different ways. And you can see your numbers and make sure everything you typed in was correct. P hat was apparently 0.272. So there we go. So this is the picture we want to draw for step 4, and we can see step 3's answer is 2.9019. So we're going to go back to the page. We'll say 2.9019. It's the ZStat, right? The ZStat is that value. And as for our picture, we're going to draw that picture. We're going to shade the tails. That's what they had. They had the tails shaded. Here, let's go back and look at it one more time. Yeah, that's pretty good. So shade my tails. Now the p-value is actually both tails put together. So if you look at how I drew it on the paper, I have p-value up here in the middle, and I have 2 arrows pointing down. That's the way you have to do this. And I have a negative z0 and a positive z0. So you take 2.909, you say negative z0 is negative 2.9019. Positive z0 is positive 2.9019. And then you write p-value up here at the top, and you say what it was, which I don't remember what it was, 0.0037. So I'm labeling everything. So this is my p-value, that's my z0, negative z0. And I put a double arrow pointing to the 2 tails. Those 2 tails together make 0.0037. All right, so now we're on to step 5, right? So StatCrunch did this and StatCrunch did this, right? StatCrunch will do both of these. You have to turn on your p-value plot, right? So give it a little check mark to turn on that p-value plot so you have it. All right, so step 5. We have to decide whether we're going to reject HO, right? Reject the null hypothesis. So it tells us right here, if the p-value is less than the alpha, if the p-value is low, we're going to reject HO. All right, so my p-value was 0.0037. My alpha was 0.01. And the way to compare decimals is to look at the first place, right, which is the 10th place. They're both zeros. So we move to the right. This is a 0. This is a 1. 1 is bigger than 0. So the alligator eats the bigger number. So my p-value is indeed smaller. 0.00 is smaller than 0.01. So my p-value is smaller. So we're going to reject HO. All right, now time for step 6. Before my pen runs out of ink here. So when we reject HO, we learned in section 10.1 there's a script. So we say there is sufficient evidence to support the claim that. And then the claim itself, you kind of have to go back up to the paragraph and figure out what it was. The claim is always the H1, that the proportion is not equal to 0.24, but that's a little weird. Proportion of what? And it's the proportion of adult Americans who believe it is easier to raise a girl has changed. It is often with these words. Whichever words that tell you it's less than or greater than or not equal to, that is frequently where the claim is. So there, that phrase is what we're going to say. The proportion of adult Americans. The proportion of adult Americans who believe it is easier to raise a girl has changed. I mean, if you want to add changed how, changed since 1947, because that was the original time frame for the original value. And there we go. We've done our first hypothesis test, all 6 steps, including our verifying requirements. The requirements will not always be asked for. Just a little FYI.